I'm Colin Hind from the CK Math Club, and we're going to be going through some problems from the 2018 MMPC Round 2. This is a 5-question test, 100 total minutes, and the 5 questions usually require a proof or at least a justification of your calculation. So I'm going to start with question 2 because I always take a test like this. The problems aren't in order of difficulty. I'll look through and I'll find the one that looks easiest. And I think it's question 2 in this one. So here we're looking at a party of people, and the degree of each person in the party is the number of other people that VI knows. And the full problem written on the paper is much more verbose, but it boils down to this. It is important that knowing someone is a symmetric relation. So that allows us, if you've done any kind of graph theory, then you immediately know the best way to represent this problem, but I think you still should write just a sentence at the start of your proof that that's what you're going to be doing. So I'll just say that. Let each VI be a vertex of a graph, and maybe I'll say we have, or there is an edge from VI to VJ if they know each other. Okay, so in case 1, it's pretty easy. We only have 4 vertices on the graph. And I'll say, because degree of V3 equals 3 implies V3 knows everyone else. There's only 3 other people at the party, so V3 has to know everyone else. And then degree of V1 equals 1, so V1 only knows V3. And finally, V2 has to know one other person, and there's only one other person to know, and that's V4. So that shows the degree of V4 equals 2 as claimed. So I guess that was pretty easy, and it's probably only worth 1 or 2 points out of 10. The main problem really is part 2, the general problem. And hopefully it jumps right out at you, not only that we should use graph theory, but that this is a problem using proof by induction. So the case I is the base case, and now we just have to see how we can use the inductive hypothesis to build up the proof by induction. So I think that the V1 and the V2 and the Vn-1 are going to be useful, right? And maybe the Vn is going to be important, and maybe the what's the correlation of V2? Well, let's think about that. So I need to keep some guys separate and some guys kind of groups together. So I'm going to mark out V1, V2, Vn, Vn-1, and and maybe also Vn minus 2 as separate dots. And every other vertex in the graph I won't draw out exactly, but I'll put them here. V3 up to Vn minus 3. And I'll note that that's a total of 4k minus 1 vertices. And so, what do we have? We'll use the same kind of reasoning here. Vn is friends with every other person at the party. V1 is only friends with one person, so that has to be n minus 1. V2 is friends with 2 people. He's already friends with n minus 1. Who else is he friends with? Well, let's look at Vn minus 2. Vn minus 2 can't be friends with V1. I'm using the word friends instead of knows. It seems more friendly. So Vn minus 2 is friends with everybody except for V1. So I've got that line also. And now V1 and V2 are not friends with anyone inside this large group, but these two guys, Vn minus 1 and Vn minus 2, are friends with everyone in this group. Vn himself is still, draw it all the way outside. Vn himself is friends with Vn minus 2, because Vn minus 2 is friends with everyone except for V1. And Vn has an unknown number of connections with all these guys in here. So, so we basically repeated this logic to draw all of these lines, and now we're going to use the induction step. We're going to say the set, we call it V star equals V3 up to Vn minus 3, but also Vn, all right, has I just realized I miscounted how many numbers are in here. If you include Vn in this group, then there's 4k minus 4 total vertices. Okay, so the total set now has 4k minus 1 friends, or people in total, and let me write it this way. Degree of Vi is going to equal I minus 2. And the reason is that originally every Vi had I friends, but 2 of them were to Vn minus 1 and Vn minus 2. So this doesn't quite match the inductive hypothesis, but the only difference is that we would have to relabel the degree of each of these guys. Subtract 2 from each degree, and it matches the inductive hypothesis exactly. We use the inductive hypothesis to conclude degree of Vn in V star is 4 times k minus 1 over 2, right, which equals 2 times k minus 1. And as we already realized, Vn has connections to all those people in V3 to Vn minus 3, plus 2 more. So we have our 2 times k minus 1 plus 2 more gives us 2k, and that's what we wanted to prove. So I think that I think this problem was a little bit straightforward for MMPC Part 2, as long as you've seen some graph theory before, and as long as you're comfortable with proof by induction. So I hope you're able to bang this one out pretty quickly.